Hi, welcome to an Arduino tutorial from Robojax. My name is Ahmad Shamshiri, presenting this tutorial from Canada. In this tutorial, I'm going to show you how we can use this AC light dimmer with Arduino so we can control the intensity of light of an AC bulb. You can get the code for this by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. So this module was available on AliExpress and it was sold on RobotDyn for $3.50, $3.49 US. They have provided some detail and also link for the library, and I was able to get the library and fix it. I will provide you this link as well. I have no affiliation with them, I just purchased it. We're going to test and see how we can use it to control the intensity of light of an AC bulb. We have 4 wires. This one is the signal that you control the intensity of light. The second pin is ZC or zero crossing. The third one is ground, and the last one is VCC or 5 volts. This AC dimmer might not work with all LED lights. Some of the LED bulbs are not dimmable. When you're purchasing an LED light that you want to dim, make sure to get the type that is dimmable. And here is an example. For example, this Philips dimmable daylight bulb. Still, unfortunately, they use the 60 watt because we are used to that 60 watt, but it's actually maybe 5 watt or 6 watts bulb. The bulb that you're getting, make sure it is dimmable. You see this is also dimmable, and some of them are not. If it's not written, then it will not be dimmable, and this module will not work with that. Now let me explain the module. This portion, this is for AC in, the green, and the blue is the load. You will try to connect the live here and the neutral here, and if you connect it in reverse, still it will work, but it's better to control it from here. So you turn it off, it will be safe that the signal doesn't pass. And this is the load. The live will go through the circuits and the neutral will go directly here. There is only one connection, that we have a bridge rectifier. This bridge rectifier has AC pin or here. That one is connected to the neutral, the other is connected through these resistors to live, and then we have DC output. This is connected to this 4N26. This is the optocoupler photoresistor output, and that pin DC is connected to pin 1 to the anode of this photodiode, which is inside this chip, and pin 2 will be connected through different means with a certain frequency to the ground, so it passes a signal, and the light will go to the base of this transistor. And this chip is this MOC3021 is the MOC3021. This is a 6-pin Optoisolator Triac driver output to drive the Triac. It can work at 115 and 240 volts to drive the Triac. Other than the few resistors that we have with these power resistors, this is a BTA16 600B Triac. Here is the data sheet for BTA16. These are the 3 pins. The gate will be driven by that Optoisolator driver. So here they say 16 ampere, but it needs huge heatsink in order to be able to handle the 16 ampere. I will provide you the link for the data sheet. The module length is 62.6 millimeter or 2.46 inches. The width is 29.6 millimeter or 1.16 inch. The height of this is 32.4 millimeters or 1.27. If you're interested in weight, it weighs 21.9 or 22 grams. If you need a wiring diagram for this, it will be available as part of my Arduino course at Udemy, at udemy.com, where you can get all the code, library, wiring diagram, and learn Arduino step by step from beginner to advanced, including the Internet of Things and programming for Arduino in advanced level. The link will be below this video. Now let me explain the wiring. Because I needed 5 volts for this and 5 volts for this potentiometer, and my Arduino does not have extra 5 volts, so I've connected this wire from 5 volts to one point on this breadboard, the red. So this is my 5 volts now. All of these are connected, and then one more wire and the ground, and this is connected to the second line here, where now this blue is all my ground. So I have 5 volts and ground available here. And here, these wires here, it says VCC. This will be connected to 5 volts. This red, I'm connecting it to this 5 volts. The second pin is here, ground. This is connected to the ground, to this blue, and the other one is connected to 5 volts, as you can see. And then we have here 0 crossing. This yellow is connected to pin 2. This is an entrapped enable pin or entrap pin. You cannot change it, it must be connected here. And the green is the last one, which is the pulse width modulation or the signal pin. This is a signal that is coming here, and we have used pin 12 here. You can change it to some other pin if you wish. For my potentiometer, because I want the right side to be maximum, so I will use this wire for 5 volts, connecting it to the any pin on that red side, and the left one is connected to the ground. Make sure that the middle pin should not ever be connected to ground or 5 volts, otherwise you will short circuit it either by rotating it to the right or left. So the middle pin will be connected to analog 0. This was my extension cord where I could plug this into the wall. So I cut it here and prepared it and connected it here so I can demonstrate this for you. Before I connect it, this wire is connected to my main power. From here, the live is labeled here. Now it's not connected. The live goes on this side, and it goes to the system and exit back. So this is my live wire or hot wire, and this is the neutral, which goes here. Internally, it's connected and comes back. Now let me explain the code. First, you need to download the library. I will provide you the link. Once you download the zip file in your computer and saved it, open your Arduino, go to Sketch, include library, add .zip library, and after that, point it to where you have saved it. For example, if it was in the download folder, go there and select the file that is with the zip. For example, if this was your file, select it and click open. After that, close Arduino IDE and reopen it. If you don't do that, you will not be able to see the list immediately on the examples. So when you close and open it again, then go to File, Example, and RBD Dimmer, Simple Potentiometer. This is the file that you will open, and I have it in front of me. I've modified it. I will explain every line that I've updated. We will be using some pins, for example, for Leonardo, Mega, and Uno. If you're using Arduino Leonardo, D7 is for 0 crossing, for Mega D2, and Uno D2 or pin 2. This is pin 7. I will be using pin 2, including the dimmer header file. This is part of the library that you have downloaded. After that, define use serial. They have defined serial here, the actual serial from Arduino. They're using it like this. And then define output pin. Pin 12 will be used. You can change it accordingly to any other digital pin that you want. And zero crossing. This is for the boards that can be changed. For Arduino Uno it is 2, and for Arduino Leonardo it is 7. So in those cases, if you can change it, you can set that. But for those pins, if you connect it to 2 and 7, the zero crossing, you will be okay accordingly. This is the line that I have added. Define pot pin or potentiometer pin for analog 0. And I have added these two lines, constant integer pot minimum 70 and pot maximum 70, which I will explain it next. And then pot valued. I have added these 3 lines. And this is, we're creating an instance from this class, and we call it dimmer, and we pass the output pin, which is pin 12 in this case. And then integer out value. This is the value that goes to the dimmer. Inside the setup, use serial.begin. This is supposed to be serial, so we have defined it up here. I've not changed it, so serial.begin 9600 baud. That is for the serial monitor. By clicking here or by clicking at the tools, serial monitor, or pressing Ctrl Shift M. This is the value that is displayed depending on this baud rate setting. If you select the wrong value, you will not be able to see the values, or you will see question marks. So let's set it back to 9600 baud, which will work properly. And then dimmer.begin. This is initializing with normal mode on. Do not change this. And then inside the loop, we read the analog pin. This value, this line that I've highlighted, was here, and I moved it here. So we read the potentiometer value and store it in here. So analog read pot pin, it goes to analog 0, reads it, and we are storing it in pot value, which we defined above. And this is a function that I have written to correct some issues that arises with this, which I will explain practically later. And then the pot value comes here. We use map, which gets the potentiometer value from 0 or from 22 to 1023, and it maps it between 100 and 0. This is a % of intensity of light, and this map will calculate that. The result of calculation will go to the out val. I have added these lines to print the text because this is inside quotation, and then pot value, the actual potentiometer value, and then I added this space after that, and then out value. This is the value that is the result of this calculation. Out value goes here. We say dimmer.set power, it sets the power, and this text is displayed in here. So we have let me stop it so you can see it. So we have pot value as a text, this pot value, and then the actual value. This is the value. You see, you don't have any quotation around this, while we have quotation. This quotation means it is a text, and then we have space here. This space is this, and then we have actual value 22, which is this value printed here, and then after that I print the percent. Percent is inside the quotation, so it's just a character we are adding at the end, so it looks nice. Now the correction for this one will be explained later, but practically, but now we say if pot value is smaller than pot minimum, which we set above, and here this minimum and maximum, then we set pot value equal pot. Anything below this will be treated as itself, and anything above the maximum will be called the maximum value. So we select a boundary to keep that value, and the loop will continuously after this goes back, read the potentiometer, correct the value, and continuously does the same thing over and over again. If I upload the original code let me go to File, Examples, and RDB meter, potentiometer, and upload this. See that if I go to 0 to the minimum, it shows 1% here while the bulb has some value. Now if I increase it slowly, 2%, so pay attention to this digit, don't worry about this. This is potentiometer value, and as you can see at 18 or 20% it turns off, then increases, and 80%, as you can see, 90, 95, and then turns off at 96. This is the maximum, the 100%. So I have modified the code that it can work within that range that I have determined. Okay, to solve the issue, I drew this line. That's for potentiometer value 0 and 1023. This is the minimum and that's the maximum. When I rotate it to the left, it will be 0, and when I rotate it to the right with the maximum, that is 1023, Arduino will read this value. And now this line is the percentage of the light, which we will find out. So 0 corresponds to 100, supposedly 1023 will be 0%. So they are opposite of each other. I just made these two lines. Now I'm at the minimum. As you can see, the light is on. I will increase slowly, it goes off, and again on. So we have to figure this out. As you can see, it works in this region. We want to figure this out. So the potentiometer is at the minimum, and I have this number. Let me increase it until it turns off. As you can see, 13%, that's a percent, and this is the potentiometer. Fully off, as you can see, it's 22. So now we can see that 22 corresponds to 804. So this is 22, assume, and this is 804. The bulb is off. Now let me increase it slowly. As you can see, the light is on now. We go further. Pay attention to this percent. It's now approximately 50%. And 68%. You can see that this is now, we are reducing the value towards here, 78%, 80, 90, until we see that 96. You see it's fluctuating. So 96 corresponds to 45. 45, which is at 96. That's our maximum. So this is our maximum. Now we record this, and also pay attention to this. We need this 22 in here. So this is now our minimum, and this is our maximum for pot or potentiometer. And also pay attention to this. Here I've added this. It says pot minimum 45 or 59. You can play with this. This is the 45, so we can put 45, and the pot max 804. So this was a value that we have experimentally Experimentally we determined that the value that we got was 22 is here. This 22 that we have here, we will enter it here, and this function works like this. If pot value or potentiometer value is smaller than pot minimum that we set, is smaller than 45. If it is smaller than 45, this potentiometer value must be minimum of 45. So if it goes below this value, we keep it 45. We doesn't allow it to go. And here there is another if pot value is greater than pot max, this is the max. If it is greater than that, then we keep it back at 804, and we say pot value is equal pot max. So this value which have been defined here, I put it here, it will be updated because this is this is a global variable and any function can update it. Let's upload the code. I'm using this AC bulb. The region that I'm in Canada, it's 120 volts and it's 60 hertz. And your region, if it is 220 or 240 volts, 60 hertz, still the same device will work. When I open the serial monitor, let me just increase this slowly. As you can see here, it shows 32%. We have a little light. When it turns off, it is about 25. So if you want to display a different value, you would see that this bulb is turning off at 25%. And here is at 96%. That's a value based on what I've experimented with. It's very responsive. Thank you for watching. This was how to use the AC dimmer or speed controller with Arduino. If you learned something and found it useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, post it at the comment section below. I try to answer and reply. If you want to get updates of my upcoming videos, make sure to subscribe.